Okay, here we are on the long-awaited third video for the third page of the review. And this inscribed polygons inside of a circle has a justification that looks like this. So the opposite angles of any quadrilateral within a circle inside an inscribed polygon are going to be supplementary. So that means that this 71 over here and angle EFG over here are going to add up to 180, and that's it. So we're going to go ahead and set this up and write x plus 71 equals 180. Subtract the 71 from both sides, and we get 109 degrees. And then what do we write as the reason? We could say inscribed polygons. Okay, hang on. Opposite angles of inscribed polygons are supplementary. Or you could even write this one right here. Opposite angles of a cyclic quadrilateral are supplementary. Both of those would work. All right, the next one, letter L, is the same thing, where we've got an x plus 9 and a 3x plus 7, and we know that all of those add up to 180. We know that they're supplementary. So I've got 4 x's, negative 9 and positive 7 is negative 2. Add 2 to both sides. I'm getting 4x equals 182. Grabbing my calculator and dividing by 4. I'm getting that x equals 45.5 degrees. Okay, on this next one, we want the measure of angle GRO. If I go back to my justifications sheet, see how this one right here has a tangent line and a radius from the center O. So if I look here, this has a tangent line and a radius. And so what does that justification say right here? It says if a tangent line to a circle, then it's also perpendicular to the radius of the circle at the point of tangency. So it means it creates this little 90-degree angle. So when they asked us for that angle over here, guess what it is? This angle is just 90 degrees. So we're going to say that the measure of angle GRO is just equal to 90. And the reason we write is tangent radius theorem. Okay, by the way, and back on this one, this is the justification for both of these. All right. So looking at this next one, this is still tangent radius theorem. On both of these. It's just that what this is telling us, when we have this tangent line and we have this radius right here, now that we know that these are perpendicular, we now know that we have this little 90 right here, and we know we have this little 90 right here. So all the rules of a right triangle now apply. So for example, here they're asking for the length of AB. It's a missing side length. So if I have a missing side length, I was given an angle, I was given a hypotenuse, couldn't I use trigonometry to find that missing side length? I'll call that x. So all the right triangle trigonometry, the Pythagorean theorem, anything you know about right triangles now applies because we have that little perpendicular. So let's go back to our trig. We're going to say opposite over the hypotenuse. Which trig function uses an opposite and a hypotenuse? Good, it's the sine function. And so we're going to say that the sine of 48 is equal to opposite over hypotenuse. Remember that we're going to multiply both sides by 20. And what we're actually going to plug into our calculator is 20 times the sine of 48. So go open up that calculator. Remember that the functions sine, cosine, and tangent are right here. So we're going to go 20 times the sine of 48. And we get 14.86 when we round to 2 decimal places. And we're going to say U for units because they didn't give us any. So trigonometry coming back into the play here. Okay, so this next one for tangent radius theorem is going to use, do you see how we have 2 sides given and we want the other third missing side? So again, when I'm missing a side, I can either use trig or I can use Pythagorean. In this case, we can use Pythagorean. And so we're going to say leg squared plus leg squared equals hypotenuse squared, or 6 squared plus the unknown squared. Let's call this unknown. And so 36 is going to get subtracted from both sides. And that gives me x squared equals 64. When I take the square root of both sides, I'm going to get that x is equal to 8. And that's U for units for my unknown side length. So when we use the tangent radius theorem, all of the right triangle trig stuff comes back into play. Okay, now notice on this next one, the picture looks different. It's got 2 tangent lines and then a circle like in between them. And that's the case for letter P, Q, and R. So if I go back to my justifications, where do I have 2 tangent lines with a circle in between them? Do you see right down here? This is going to be the tangent-tangent angle theorem. And this says that the measure of the tangent angle is equal to half the difference of the major minus the minor arc. The big minus the little. Okay, so let's go take a peek, and we're going to use the tangent. See how it says tangent angle theorem, but I'm using that little symbol for angle. So we're going to write tangent angle theorem. And that's going to be for all of these. Okay, so it says that the measure of the angle SOC, so the measure of the angle SOC is what we're trying to find, but we need to go do the tangent angle theorem using this angle down here. So whatever this degrees is, x, which we're trying to find, let me move this up a little bit, then this one up here is going to be 360 minus x. So we've got major, we've got 1/2. Let's write the entire theorem out. Measure of angle B is equal to 1/2 of the major minus the minor arc. Big minus little. So this one's going to be the major of 360 minus x, and that's going to be equal to this 31. So now if I multiply both sides by 2, I get 62 is equal to 360 minus 2x. I'm going to subtract 360 from both sides, grab my calculator. 62 minus 360 gives me negative 298, and divide by negative 2. Divided by, I'm getting 149 degrees. So if this little SOC is 149 degrees right here, then the central angle is also 149 degrees because central angles equal arc measure. Okay, on this next one, we're looking at this right here is an 82. So we know that the big arc has to be 360 minus 82. So grab those calculators, see what you get. Did you get 278? Good. So here we go. So this big guy is 278. The little guy is 82 because central angle equals arc measure. So it wants CED, this angle right here. And so the rule says the measure of angle CED is equal to half the measure of the major minus the minor arc, big minus little. And so half of the 278 minus 82, grab your calculators. 278 minus 82 is 196, and half of that is 98. So measure of angle CED is equal to 98 degrees. Now we wrote the tangent-tangent angle theorem right up here. Okay, last, let's go purple on this one. We're noticing that this angle is going to be equal to, the big minus the little, half of that. And we don't have any numbers there. So again, we're going to give the value of AB. We're going to give this a value of our unknown x. That's what we're solving for. And that means that this outer part has to be 360 minus x. So this is again like letter P. So we're going to say that the measure of angle C is equal to half of the major minus the minor. And that means it's half of 360 minus x minus x. And then that's equal to 36. This right here is 36. So 36, multiply both sides by 2 to get rid of that half, is going to give us 72 is equal to 360 minus 2x. So let's minus the 360 from both sides. Grab your calculators. 72 minus 360. And then divide that by negative 2. I'm getting 144 degrees. Sorry, actually U for units. Hang on, what are we finding here? We're finding a measure, so degrees. And then back here on this one, we were finding an angle. So that's also degrees. And then back here on this one, we were finding an angle. So this is also degrees. I already had the degrees. Okay. That guy's all done. All right, so this page 1, remember, was already on the key that was attached.